Okay, so for number 13, you're given two triangles. So which method do you think you should be doing? Similar triangles. Okay, it's good. So and then same thing with number 14, you're given two triangles. So these ones are pretty straightforward. I want to take up number 15 and 16 because these ones are a little harder to see and more likely for you to make a mistake. So for number 15, how many triangles do you see? How many triangles do you see in number 15? Triangles. Yep. Two, right? So just like with these ones, when you're given two triangles, you know that you should probably do similar triangles. And that's exactly what you have to do. Your two triangles are this one right here and the big one right here. The whole triangle. Okay? Why I do the color code is because that's how you know how long the lengths are of what you're trying to compare. So this whole length on the bottom, 18 plus 6, that's 24. Okay, so when you do your comparison, you're not using 18, you're not using 6, you're using the whole length 24 because that's the length of the big triangle. So the length of the big triangle is 24. The length of the small triangle is 6. Equal, the length of the big triangle is 12 over the length of the small triangle right here, this, what we don't know, we'll call it x. Okay, so this part right here between B and U, that's x because that's the length of the highlighted triangle. So like that. So you cannot solve for this right away because this is not part of a, this itself is not a triangle, it's a trapezoid again. So cross multiply, 24x equals 72. So when you divide it, x equals 3. So if I know that this whole length is 12 and this part right here is 3, that means this question mark right here is 9 centimeters, for example. Obviously, this is not drawn to scale, okay? Because this part looks longer than this part, but it's not to scale, but in terms of the math, that's how you would solve it. Okay, how many of you did get 9 centimeters for number 15? Okay, so good, but this one was a tricky one. Okay, number 16, similarly, you have to figure out your two triangles. So your first triangle is this small one right here. And the second one is the whole triangle. So for this, why can't we use SOHCAHTOA? Why can't we use SOHCAHTOA here? Yep. Yeah, it's not a right angle triangle. I never said the angle Q was 90 degrees. So it's not a right angle triangle, cannot use SOHCAHTOA. And the fact that I'm given two triangles tells me I should probably do similar triangles. So, yeah, so length of the big triangle here is 12. Length of the small triangle here is 6. Length of the these two lines? Yeah, they should. Good point. Yeah, so we'll say, yeah. Yep. Sure. Oh, you thought it was Fabio? You really miss her. Okay. And then for this one, we're comparing the 22, the diagonal, with the length of the small triangle. In this case, we could call it x. Right? So cross multiply 12x equal 22 times 6. 22 times 6, you get 132. And then when you divide it by 12, you get 11. So 11, for example, centimeters, because we were solving for a length. Okay. On the test tomorrow, you will be given units. So for all length, remember to add in units: centimeters, millimeter, kilometer, so forth. And then for angles, round to the nearest degree. The little circle on the top right. Okay. So in this these two, notice this one, we solve for x here. And then we had to use this answer to figure out what the question was actually asking. This one, we solved for x here, but that was the answer because this was the length of the highlighted triangle. Okay. So, okay, and then let's do this one. Okay, the triangles in each pair are similar. So they're telling you that it's similar. So I'm going to compare this length with this length, and then this length with this length. Yep. Yeah, technically they need to give you a little bit more information. So like, for example, a little dot, like this, and then some symbols. So this question is missing a few symbols right here. Okay. So on the test, I'll make sure I add in those symbols. Okay. And then, so you're comparing the highlighted line to the highlighted line. So 11x minus 4 over 50 equal the same ratio as 70 over 60. Remember, as I said earlier, the most likely mistake that people make, like 90% of the questions, the people make the mistake on writing it in the wrong order. Okay, so remember, if you're starting with this triangle, you have to start with this triangle. Okay, cross multiply. So 60 times 11x minus 4 equal 50 times 70. So you have 660 x minus 240. Wait. Yeah, equals 3,500. Okay, move that 240 over by adding. So you get 660x equal 3,500 plus 240, 3,740. And then when you divide it by 660, you get 5.7. Okay. Should I add in units here? Is it centimeters? No. Good job. You were solving for x. So x is just a number right here. Okay. Good. Okay. So for this one, there's no units because you weren't solving for a length. You were solving for x. So how long is this length right here then? 11 times 5.7 minus 4. That means this length right here is 58.7 centimeters, for example. Okay. Okay, let's do just one more. Let's do this one. We'll take up this one as well. Okay, so highlight the sides that you're comparing. So I'm comparing this side with this side, and I'm comparing this side with this side. Okay, so again, I need the little symbols to show that these are parallel lines, because if they're parallel, that means that the angles are the same. That means they're similar triangles. Okay. Technically, I could use the 27 and the 72, or use the 36 and the 96. Doesn't matter. You were given all three sides. You could have did either or. So let's just say I did 27 over 72. And so this one would be -4 plus 4x over 64. Smaller triangle to the bigger triangle, smaller triangle to the bigger triangle. Okay. Cross multiply and divide. Okay. So 72 times this, so 72 times -4, -288 plus 288x equals 27 times 64, 1,728. Okay. Move that 288 on the other side, so plus 288. 288x equals 2016. And so when you divide it, 288, you get 7. All right. Again, not 7 centimeters because you were just solving for x. So that means this length right here would be 24. -4 plus 7 times 7. -4 plus 4 times 7, you get 24. Okay. All right. On to the back. These ones right here. Okay. For questions like these on the test, you will get a mark for drawing the diagram. So make sure you draw a diagram. If your math is right but your diagram was wrong, you will still lose a mark. Right? And for all of these, it's a right angle triangle. So to make life easy, I'm going to draw my right angle triangle first for all of these. Okay, and then I'm just filling in the information. An airplane is flying at an altitude of 6,000 meters. What's another word for altitude? Yeah, height, right, that's it. So that means 6,000 meters goes right here. Directly towards the coastline at an angle of depression. So angle of depression. So that's the airplane. Remember, angle of depression means from a horizontal line down. So this right here is your angle of depression of 14 degrees. Okay. How much further to the nearest kilometer does the plane have to fly before it's directly above the coastline? So you're looking for x right here. Right? So you could either figure out that this is 76 degrees because 90 minus 14 is 76, or this is a Z pattern. So if that's 14, this is also 14. Okay, so either or, you can either use the 76 or use the 14. So I want to use that 14. So angle of depression here is the same as the angle of elevation down here.
Do you know which is that angle? Like how to label that angle of depression?
How do you know how to label the angle of depression?
Like I wouldn't know that's the angle of depression.
Yeah, because the definition of angle of depression is from the horizontal, from the horizon down. So that's why in that lesson that we did with angle of elevation and angle of depression, I always say you have to draw that dotted line, the dotted horizontal line.
And how do you
This one, there's no name for it. This is not an angle of depression or elevation.
So basically, it needs to be right below a horizontal line.
Yeah, exactly. And elevation would be right above the horizontal line. Okay, so in this case, that means from this angle, this is opposite and this is adjacent. So TOA. So tangent 14 degrees equals opposite, which is 6,000 over x. Since my variable is on the bottom, that means I'm dividing. So 6,000 divided by tangent 14. And you get 10, 14. You get 24,064 kilometers. Okay, it might sound very big, but we're talking about airplane.
That's meters. 86,000 meters.
Oh, thank you. Thank you. So this is in meters, and then they want you to convert it to kilometers. So how much is this in kilometers?
Just 24.
Yeah. So what would you do to convert to kilometer? Divide by 1,000. Yeah, kilo is 1,000. So when you do this divided by 1,000, you get 24.0. What does it say? Oh, nearest. Yeah, so just 24. Nearest kilometer. Okay. Number 32, from a horizontal distance of 80 meters. So that means this is 80 meters horizontal. So that's how I know. The angle of elevation to the top of a flagpole is 18 degrees. Okay, angle of elevation from your horizontal line up. That's your angle of elevation. Calculate the height of the pole. So this right here. Okay, so again, it's Sokotoa. 10 opposite is x over adjacent 80. Since my variable is on the top, that means I'm multiplying. So it's 80 times tangent 18. 80 times tangent 18. And you get 25.99. Round to the nearest tenth of a meter. In this case, it's actually still 26. Okay, a 9 meter. Okay, so another right angle triangle. So see how like with these ones, once you draw that right angle triangle, it's so much easier to visualize. So the diagram is actually not that bad. A 9 meter ladder rests against the wall. Okay, so this is your ladder right here. 9 meter. That's your ladder leaning against the wall. The bottom of the ladder is 1.5 meters from the base. Okay, so this is 1.5. It's 1.5 meters from the wall. Determine the measure of angle between the ladder and the ground. Okay, so this is the ground right here on the ground. So that means the angle that you're looking for is this one, not here. So let's call it angle A, for example. Okay. So Sokotoa, adjacent, hypotenuse. So Sokotoa, which one do we use? Adjacent and hypotenuse. Yep.
Cosine.
Cosine, good.
And also, you could use the Pythagorean thingy to find the other side, and then you could like sine law.
Yeah, you could. But that would be extra work. But yeah, you could do that too. Okay. So 1.5 divided by 9 is 0.166666. Don't forget to take 4 decimal place when you do the ratio, because otherwise you'll get rounding error if you just do 0.17 or 0.2. So whenever we want to find the angle, we have to do the inverse. Okay, and so when we do the cosine inverse on the calculator, inverse cosine, you get 80.4. It says nearest degree, so 80 degrees. All right. On the test, make sure your degree sign looks like a degree sign and that it doesn't look like 800. All right. I've seen people's degree sign look bigger than a 0. Okay. Okay. Next one, same thing. Draw the right angle triangle. Angle of elevation of the sun is 68 degrees. Angle of elevation, that means I know is this right here, 68. When a tree casts a shadow of 14.3, where do you see shadows again?
On the ground.
On the ground. So this right here is 14.3. Okay. Trust me, tomorrow you'll see a question about shadows. Okay. Make sure you don't put your shadow here. Then you'll be using the wrong Sokotoa. right? And then here's the tree, okay? And you're looking for that. Okay, so some people were asking, how do I know that this is here and not the sun over here? Okay, well, if you're thinking of the angle of elevation of the sun, that means from the sun looking upwards, you're looking at a planet or something, right? So if you're thinking logically, then if your angle of elevation is not towards a planet, it makes more sense that your angle of elevation is down here. Okay, so like to the sun. Okay, so
Wait, does that mean that the tree is directly under the sun?
yes.
But
So opposite over adjacent, so 10, 68 degrees equals x over 14.
if
Point
the tree is
three.
directly under the sun, then it would have like basically no shadow.
Well, actually, no, it doesn't have to be. Like your sun could be over here. And then here's your tree. Right. All right. So you can see even if you extend it, your angle of elevation is still the 68.
Oh.
Yeah. So you're right. Both of you are right. All right. So since my variable is on the top, that means I am multiplying. So 14.3 times tangent 68 degrees. So you get tangent 68 degrees, 35.4 meters. Perfect. Okay. And it makes sense. Yeah, the height of the tree, the taller your tree, the longer the shadow.
You round to 4 decimal.
Oh, when you do like tangent 68 degrees as a ratio, or when you divide the two numbers. So even right here, when I do it this way, I don't even take 4 decimal place. I take all the decimal place. So tangent 68 is 2.4750. When I do this on the calculator, I'm taking all that decimal. But if I just take 4 decimal place, so 2.4751 times 14.3, I get an accurate answer. But if I just did 2.5, for example, 2.5 times 14.3, okay, notice I get way off. So I get rounding it.
You just always round to 4 decimal.
Yeah, you could. But for final answer, it will tell you what to round to. Yeah. Okay, next one. Draw another right angle triangle. Wheelchair ramp is 4.2 meter long. So this is 4.2 meters. It rises 0.7 meters. What is the angle that it makes? Oh, angle of inclination means the same thing of angle of elevation. So this is what is the name of this symbol?
Sine. Wait, theta.
Theta, right. Okay, so you'll see this Greek symbol, it's called theta. You use it a lot in math and science. It just means angle. So instead of calling it angle A, I call it angle theta. Okay. It's just a variable. Yeah. Okay,
So
so
what is it called?
theta.
No, like in there's like a related like acute angle which is B, and then there's that one, but it had like a name.
Beta? Beta.
No.
Yeah, usually it's theta and beta.
Like there was like the related acute angle which is B, and then like there's
B
theta,
is-
which is something else.
Usually the two that we use the most is theta and beta. One looks like this, the
No,
other
but,
looks
it
like
has
this.
like an English name that's like 2 words long.
I'll think about it.
It's like when you have like, like an XY plane, and then like the angle theta like goes around the whole way, but then the angle beta is just the related acute angle.
I'll think about the word. So 0.1666. Okay. So when you divide it and then do the inverse, you get 9.59. It says to round to the nearest degree. So in this case, it will round to 10 degrees. Okay. This may sound stupid, but it's a silly mistake that I see as well. Notice here you're using sine. So when you do the inverse, you're doing the sine inverse. I've seen people see this and then they do this on their calculator. Okay? I know, eh? Yeah, so this is a common mistake as I see as well. So if you're doing sine, make sure when you do the inverse, you also do sine by pressing the sine button. Yeah.
So I have like two questions. First of all, so you have to do that first time where you say sine theta is equal to that fraction, and then you have to do theta. Theta is equal to your sine.
Well, how much work you show? Well, for example, let's say you don't show anything and do this. Okay.
Well, that one step after, you're not really doing anything.
Well, I can tell that you, like, in case you did something silly, I can still give you the mark with that. So that's like how much work you show. In case you get it wrong, you'll still get part marks.
Can you keep it as a fraction, or do you have to make it decimal? Like do 0.7.
Like you mean from here to here?
Yeah.
Yeah, you can keep it as a fraction. Yeah.
What if a couple numbers like variation on the test? Does it have to be an exact number? Because like if you don't use the formula, instead of just typing sine 0.7 divided by 2, we round down to 9.
Really?
Yeah, I'm not
Sine inverse. Did you use bracket? 0.7 divided by 4.2. No, I still get the same thing. Yeah, of course. After you got the whole class attention, of course, their calculator decides to trick you. So last one, a person flying a kite. So again, okay. Flying a kite released 176 meters of string. So if you ever flew a kite, you know that this diagonal right here is the string. Okay. So where are you? Are you here or here? On the ground, yeah. So that's you.
You're in the sky. You're on the
Okay. So I'm trying to cover all the grounds so that, tomorrow when you draw your diagrams, you don't think something abstract. Okay, the string makes an angle of 27 degrees with the ground. So 27. Okay, so realistically, you got really tired and then you just drop your ball of string on the ground and then it made an angle of 27 degrees. Okay, because otherwise you would have to consider the height of your head, right? So how high is the kite? That's what I'm looking for right here. And then how far away is the kite horizontally? So there's actually two parts to this answer. So first off, SOHCAHTOA, opposite over hypotenuse. That means I am doing sine. So sine 27 degrees equals x over 176. Since my variable is on the top, that means I'm just multiplying them. So 176 times sine 27 degrees, I get this answer to the nearest meter. So it is? What do I round? 80, right. See, silly mistakes. 80 meters. So 80 meters high. Now to find this, what are my two options to find y? Yep.
Sine law.
Not sine law. Yeah. No. Yeah. Well, it involves a few more steps with sine law.
Okay, but like, so there's two easy ways to find it. First, like, because that's like easy.
Right. So I could either do SOHCAHTOA again using adjacent over hypotenuse, or Pythagorean theorem. Use the easy methods. C squared minus B squared. Okay, since I'm looking for the odd length. So 176 squared, take away 80 squared. So 176 times 176, you get that 30,976, take away 64,000. So A equals square root of 30,976, take away 64,000. Oops. Where's my delete button? I put a one too many zero. How do I press? Where's my delete button? Where?
Yeah, no, you know your pen is pointing to it. Up a little bit. Yeah.
Oh, there. So much to just delete a digit. Okay, 24,576. So square root it. Square root the answer. 157 meters. Okay. If you did cosine in SOHCAHTOA, you would get the same answer.
Not easier and less likely to be messing up because you have to write so many less digits.
Well, this one I just wrote down all this, but technically you don't have to write.
Both ways work.
Yeah, both way
Done it
works.
using sine law, and it would have been so much easier.
Well, sine law, you had to first find this angle.
Well, even 180 minus 90 minus 27.
Yeah. Okay. And again, another silly question. How do I know what this angle is? Yep. Yeah. So remember, all angles in a triangle add up to 180. So that is 63. Okay. So there you go. We actually solve for everything in that triangle. We solve for all three lengths. We solve for all three angles. Okay. Okay. So I have this last package. I was gonna take this up with you guys tomorrow because you guys have the but since you guys have the test tomorrow, yeah, I think it's doable, all of this. Yeah, so just more trick word problems for you guys to try. Again, I didn't give you guys any diagrams so that you guys get more practice on it. So on the test, if I give you the diagram, then it will be easier. These ones right here are multi-step trick problems, which means as you can see, there's two right angle triangles, so you have to do SOHCAHTOA twice. Okay. Now this one right here on the bottom is just find the area of each triangle. How do I find the area of a triangle? What's the formula? Yep. Base times height divided by 2. So for example, this question right here, I would have to use this right angle triangle. I would have to do I would have to do SOHCAHTOA to find the height of the triangle. And then I would have to do SOHCAHTOA again to find the length of this right here so that I can have the whole length of the base. So then base times height, and then you'll get the area. Okay, why don't I do one with you guys. Because otherwise, I think you guys might have might run into problems tonight when you get to this question. All right, so this one, even though I see two triangles, can I do similar triangles? Why not? Because it's not similar, right? The shape itself, you can tell, is not the same shape. Okay, this angle is different from this angle, different from that angle. So remember, the definition of similar triangles is that all angles have to be the same. So this triangle definitely don't have the same angles as this triangle right here. So I have to do SOHCAHTOA to find x. All right. So SOHCAHTOA, given this, so this is opposite, that's adjacent. So tangent 70 degrees equals 46 over x. Okay. Since it's on the bottom, I have to divide. So 46 divided by tangent 70, I get 16.74. Okay. I don't want to round yet because this is not my final answer. Only round final answers. So I found this. Now I need to use the x to solve for this triangle right here. Okay, given this is 44, that's opposite, that's adjacent, so another tangent. So tangent 44 degrees equals opposite. Oh, whoops, sorry. I know what x is. X is 16.74. We just solved for that. Over adjacent. Okay, so looking at this triangle, now I want to figure out what y is. This part right here. All right, opposite, which is 16.74 over y. So y equal, when you divide it out, that divided by tangent 44, you get 17.34. Okay, so now that I have all the information, I can do my area because the question was asking you to solve for area. Base times height divided by 2. How long is the base? How long is this whole base right here? What do I have to do to find a whole base? Yeah, Paul? Okay, how did you get that? 46 plus the 17.34, right? Okay, that's why we had to figure this out in the first place. So when you 46 plus 17.34, you get 63.34 times the height. What's the height of that triangle? 16.74. And then divided by 2. Okay, times 16.74 divided by 2, you get 530.2. Let's say the lengths are in centimeters. Then what would my unit be right here for area? Yep, centimeter square. Good. Okay, so you see how this question, multi-step. All right, so it might be a simple question asking you for the area, but you would have to apply your knowledge to know that, okay, that means I have to find this length, which is the height, and I need to find the base length, but I'm missing part of my base, so I need to do SOHCAHTOA again to find this part. Okay, so there you go. So you guys have about 20 minutes left. Try all this. There are plenty of questions for you guys to try. These last one right here, I didn't even do a dotted line. I want you guys to draw that dotted line to figure out how to calculate the height in the base. All right, so there you go. I'll hand this out and I'll upload this review video if you need to review it at home.